And continuing on with the new electrolysis series, I want to show you this cell because this is something I think it's time to show you. And there's a lot of people that don't want you to see this for various reasons. But I'm going to show it to you anyway as long as I can. This particular configuration, this small coil with this one wire in between the coil. It's in a beaker of ordinary tap water. It comes off of here on these two wires, goes into a special diode arrangement I have for charging. This switch right here is used for switching this LED in and out of the circuit. I use the LED for tuning for maximum current into the battery, and then once that's obtained, I take and switch the LED off, and in return switch in a diode to replace that LED so that we're not wasting the photonic energy coming out of the LED. Off of the back side of this board, I have my two leads going up to my voltmeter here, which is going to be reading the voltage on that battery. Now this is a nickel cadmium battery, and it is totally discharged. I mean, it is smoked to no end. It was allowed to drop well below the 1.1 volt level. This is a 1.2 volt 700 milliamp hour battery. So we may or may not see results here, but I think it's quite worth showing it to you so that you get an understanding of what's taking place. Now let me explain to you what we're going to have happen. When I turn this cell on, and I'll explain this configuration later, it's quite unique. It's a way of capturing all of the coherent energy that is taking place within the exciter and the coils, and we're going to have electrolysis occurring here, but that right now is not going to be what I want to show. I want to show you how we're going to charge a battery, and later in another video I'll show you how we charge a very large capacitor so we can actually get a more meaningful representation of what's taking place, because in order to tell what that battery's doing, we're going to have to put it on the electronic load and over a period of time discharge it at a known current so we know exactly how much energy we put into it. That's kind of mundane and very time consuming, so what I'm initially going to do is just show this to you, and then we'll move into the capacitor, which is a whole lot easier to get some numbers off of. So what we have here basically is the positive lead coming out of the power supply going straight down to this connection here. The negative lead from the power supply snakes around here, goes to the one side of the SEC exciter. There's also a diode here that goes to the same negative terminal that goes back up here to the positive terminal. And like I say, I'll explain that later. That's irrelevant at this point. Now, what's very important here, when this battery begins to charge, we have to pull current out of the positive terminal and put it back into the negative terminal, correct? If we're looking at electron flow, we're pulling electrons out of the negative and sucking them into the positive terminal. That discharges the battery. What we're going to do here is the absolute reverse of that. We're going to pull electrons out of the positive and put them back into the negative terminal, thus charging that NiCad. Now, when that happens, current's going to have to flow between these two wires down here, this loop of wire and this straight wire down the center. Now obviously what's going to happen when current flows through those two wires? We're going to get electrolysis. So we have no physical connection except for the excitation from this small piece of aluminum foil off the side, and this L3 is going to excite this arrangement in such a way it's going to produce gas while it's charging the battery. And when the battery is the most discharged, we'll have the maximum current. and as the battery charges up, the current will decrease, so the gas does decrease as we go through the charge cycle. But be very well aware of the fact that there are no physical connections to this battery at all, with the exception of this voltmeter. And what we're going to do is excite the speaker. Yes, you'll see a lot of gas coming out of this arrangement, and you won't see all that much gas coming out of here, but you're going to see enough to know that we have a good electrolysis rate taking place, and we're going to be able to see the voltmeter and see the charge going into that battery. And so we're getting 2 for 1 here. We're going to be charging the battery, and we're going to be producing gas at the same time. So let me go ahead and fire it up. Okay, so what we have now is I've fired it up. I'm putting 18 volts into it. I'll show you that in just a second. You see that blinking light? Well, what we do is we take and adjust the frequency on the exciter to where we get maximum charge current going into that battery. We'll flip off this LED. And now what we can do is go up here and we'll look at the battery charger. We're running 18 volts, 48 milliamps, 800 milliwatts. And here is the connection across that NiCad battery. Now, I'm going to show eventually this is not a ghost charge. This is an actual real charge into that NiCad. And if you know anything about NiCads, you can actually tell the charge state by the voltage until when it's fully charged, which is about 1.325, somewhere in that area. But anyway, we can see that here's what we're putting in: 48 milliamps, 800 milliwatts, 18 volts, and you can see the rate at which it's charging this NiCad battery. Now if you want to see gas, we'll move in here and you can see what is happening in this one cell, which I say is somewhat irrelevant at this time. And then we have this other cell, which is what's actually charging the battery. And you can see the gas on both electrodes and the bubbles flowing up to the surface. So we're producing gas at the same time we're charging this battery. Okay, so that's enough for this one. We'll take and go ahead and let that go for a little bit. We'll cut another video and get that up and explain exactly what's taking place down here and why we have so much gas being evolved from that little circuit.